Let's spend this video talking about reference angles. This is something that came up during our construction of the special angles on a unit circle. But let's treat this idea in isolation in this video. Right? So the basic idea, if we're given some rotation theta in standard position, and look at the terminating side, then the reference angle in this picture is the acute angle between the x-axis and the terminating side. Reference angles will not always be strictly acute, but they are going to fall between 0 and 90, or in radian measure between 0 and pi over 2. So let's take a look at some examples. Suppose theta is 130 degrees. Let's find the reference angle. So in standard position, rotating 130 degrees brings me in quadrant 2. 180 degrees would bring me all the way to the x-axis. So this acute angle here must be 50 degrees. And that is my reference angle. What if our given angle is 7 pi over 6 and we want to find the reference angle? Well, rotation of pi brings me to here, so 7 pi over 6, that's right here, lands me in quadrant 3. Since I used up pi radians to get to the x-axis, the angle between the x-axis, the acute one between the x-axis and our terminating side, must be pi over 6. So the reference angle here is pi over 6. A couple more. Negative 40 degrees. That's going to be a clockwise rotation. That puts my terminating side in quadrant 4. So this angle here, right, that's a negative 40 degrees, but remember that our reference angle must be positive, somewhere from 0 up to 90. So as far as my reference angle is concerned, it's going to be a positive 40 degrees. Let's do one more. Let's do 7 pi over 2. Okay, 7 pi over 2. So let's see. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So 7 pi over 2 puts my terminating side on the y-axis, pointing straight down, right? So my reference angle, you can think of it from either direction. In either case, the reference angle is pi over 2.